All right. So we can start with our next session. I hope also the people online can hear me well.
Yes.
It's a great pleasure to have Falk here today. Falk is a research group leader at the Max Planck Institute for Intelligent Systems here in Tübingen. He is leading the Rationality enhancement group, and Falk was already here with us in the first iteration of the summer school in 2019 in Freiburg, and it's a great pleasure to have him again. So thanks very much that you could make it. And without further ado, the stage is yours.
It is our computational science research techniques to improve decision-making and to learn framework for thinking about other constructions and other approaches that you can take to better your critical science and skills for the research about eventually. There's a big motivation behind all of these.
Sorry to interrupt again. Maybe we can try to make that mic a little bit louder.
Yeah. Please. How about now? Is that the last time that we will be doing? Is it on? Okay, so we can be more now.
No, I think it's still not really working well.
But so through the catch box, it's working, right?
Ja, hello.
So you can hear us through the catch box, right?
Yes.
Yes.
Yeah. Yes.
I cannot hear anything.
Ja, natürlich.
Hallo.
Ja, okay.
Alexa, can you hear the
I'm not sure. Wait a second.
But you can leave it and we speak it around. So there's something here and like a microphone, then there's a connection.
Then people have to ask questions.
Yeah, then
Yeah, we
have to read
can
the
arrange.
question. If there's something from the room. Yeah. But
I'll
then you don't
take it.
Ich kann euch jetzt hören.
It works now?
Yeah.
Ja, also ich sehe, das Bild ist eingefroren, aber ich kann euch hören.
Okay.
Und vielleicht können wir das vordere Mikro ausmachen, das am Pult, oder? Weil sonst halt es noch zusätzlich vielleicht.
And because this is not used anymore.
Oh, okay. Okay.
I'm not sure it's out, but okay.
All right, with this talk, I'd like to illustrate how you can use computational cognitive science to improve human decision making. People in the world today have tremendous opportunities to do good and make the future really bright and influence in a very positive way. At the same time, we also have the capacity to completely destroy our future. Therefore, the decisions that people make today really have a tremendous impact on the future of humanity. And that puts us as cognitive scientists in the position to potentially have a big positive impact by laying the scientific foundation for improving those crucial decisions. To do that, we need good models of the underlying cognitive and emotional mechanisms that drive people's decisions so that we can either design decision situations with those mechanisms in mind or improve those mechanisms. We can do that through educational, technological, psychological, and also regulatory interventions that shape people's decisions. And those interventions should be based on a really solid understanding of what the mechanisms are and what good decision-making actually is. There are three types of approaches to improving decision-making. I think computational cognitive science contribute to all of them. The first one is improving people's decision-making literacy. Here, computational cognitive science can contribute by using normative modeling in order to identify what optimal decision strategies are that can then be taught to people, and also by finding out how people can learn how to make better decisions so that we can have a pedagogy that's informed by the underlying learning mechanisms. The second class of approaches is to changing the decision-making environment in such a way that the decision strategies and intuitive mechanisms that people normally rely on will lead to better decisions. Here again, having good computational models of what those mechanisms are can help us design the environment so as to optimize the outcome of the decisions given the way that people usually choose. And finally, we can develop decision-making tools that outsource some of the parts of decision-making that are difficult for people and where they're prone to make errors to machines, and basically create a hybrid system with a human and algorithms that together can make better decisions, and the algorithms compensate for human weakness. These different types of interventions fall on a continuum in terms of how much they influence the decision maker and how much they respect or even enhance the autonomy of the decision maker. At the lower end of this spectrum, there are laws and regulations that compel people to take certain actions, very strongly restricting their autonomy, but at the same time also potentially having a very strong impact on the resulting behavior. On the other side of the extreme, there's boosting, where you increase the decision maker's competence to choose what they like best, basically enabling them to make their own choices in their own interest according to their own values and their own beliefs. And in between, there's nudging and financial incentives. With financial incentives, you may give a tax rebate for recycling, for instance, or for using electric cars rather than conventional cars. And with nudging, you're changing the environment a little bit so that people are more likely to intuitively choose the option that is deemed better for society or better for themselves, without restricting their freedom in any way. They're still free to choose whatever they want, but the way that the choice is presented to them makes it more likely that they will choose something that is socially or individually desirable. These different approaches can all be used for good, and there is research showing that all of them can be effective at promoting socially beneficial behavior. So there's a recent meta-analysis on boosting prosocial behavior, for instance, by helping people to evaluate which charity is most effective using actual impact information about how many lives are saved per dollar donated, and that can help them to do much more good with the resources that they're willing to invest to help others. And there's also research on nudging, that where nudges are used for good, you can establish socially beneficial norms. You can make the default choice the thing that is better for the greater good or for the individual, as with automatically involving people in organ donation programs or retirement savings, while still letting them opt out if they don't think that's a good idea. Now, while all of these approaches are already being pursued, I think we could do much better at many of them, but there are several scientific obstacles that we have to overcome. So for instance, designing good boosts and training programs for increasing people's decision-making competence is currently difficult because we don't really have a very solid understanding of what good human decision-making actually looks like in the real world. We have certain normative theories that entail astronomical amounts of computation for complex real-world problems. So we can't really instruct people just maximize expected value or expected utility or expected welfare, because that's just intractable. So, and then there's a vacuum between that and saying, well, here's a practical heuristic that some people say works well. Why don't you just do that? So there's a vacuum in between that I think computational modeling can fill to identify practically useful normative decision strategies that we can teach people to increase their decision-making competence. Moreover, different types of decisions and different types of people may benefit more from one type of decision strategy versus another. So it would be helpful to have a theory that allows us to identify what is the most effective boost for a particular type of decision in a particular situation. Moreover, the process of designing these education interventions and decision tools is currently still a lot of manual labor that requires ingenuity and a lot of work. If we could automate some of that, we would probably see much more boosting and more decision support. And in this talk, I will introduce a theoretical framework that can help us with all of those things. And I'll illustrate how it can be applied to boost and also nudge people's decisions for the better. I'll first introduce this framework, which is the foundation for the approaches that I'll introduce. So I already said that people's decisions can have a really big positive impact. And I think in order for people's decisions to have that impact, people need two things. One is altruism, so the desire to actually benefit the greater good. And the other one is rationality, the ability to use reason and evidence to work out what course of action would actually achieve that goal of maximally positively impacting other people in the future and animals. Now, from a mathematical perspective, what we would like, what's kind of optimal decision making would be to maximize the social impact of the actions that you take, where the social impact is basically the difference between how good the world would be if you take this action versus how good the world would be if you didn't. Now, of course, we cannot exactly predict what the outcomes of our decision will be. There's so much uncertainty, so many things that could happen. So therefore, we can't really maximize the social impact, but we can maximize the expected social impact. We're basically integrating over all of these possible outcomes and scenarios, and we're taking the expected value of the social impact, and we're trying to maximize that for our decisions. So this is a computational level theory of optimal pro-social decision-making that can be a starting point for us as we are trying to derive what kinds of decision strategies people should use and do use in order to pursue that goal. Now, as I already alluded to, maximizing expected social impact is not a practically viable decision strategy, because if you try to do it, you would get stuck evaluating even just a single option that you might pursue now, and you would be evaluating it your entire life, and then you would die, and then it would be over, and you would never have done any actual good. So that's not actually a good strategy. And the reason is that it's just too computationally intense. So a practical strategy has to take our finite time and our finite computational resources into account. Otherwise, we don't have a good theory of what good decision strategies actually are. It is possible to make good decisions with relatively simple heuristics. For instance, in the area of career choice, there's a simple series of questions that you can ask yourself in order to identify a career path, which you can do much more good than you would otherwise do, using your strengths and your interests. So this is a simple series of questions, and that's an example of a heuristic decision strategy that might work reasonably well. But is it the optimal one? Probably not. We don't know. What would an optimal decision strategy for career choice look like? We don't know. But I'm going to argue that we can use computational modeling to work towards answers to such questions. And there's already prior research arguing that teaching people simple heuristics that are well adapted to the structure of the decision-making problem and the environment can be an effective way to help people make better decisions. And some studies that have been successful at improving people's decisions by teaching them heuristics that have come out of this research paradigm. But what is still missing in that paradigm is sort of a really solid computational theory that says what heuristics are optimal in which circumstances. Because without that, there's just a vast space of possible heuristics. There's like infinitely many possible heuristics. And it is not helping us very much to say that the heuristics that we recommend to people have to be ones that they can actually execute in a finite amount of time, because that is still an infinite space of possible heuristics. And we're still clueless about what people should actually do. And if you're trying to understand what people do just descriptively, trying to model human decision-making, we're also pretty clueless about where to start. So the framework I'm proposing is to use the heuristic that makes the best possible use of people's finite computational resources and limited time as this starting point for exploring what mechanisms people might use and boosting human decision-making. So the heuristic that we should teach people is the one that makes the best possible use of their limited time and bounded cognitive resources. And I will become more precise about what exactly that means. So this framework that I call resource rationality combines decision theory, so expected utility theory. It also combines insights about bounded rationality, and in particular the importance of the structure of the environment for what decision strategies are good, and also takes into account the research on cognitive limitations by Kahneman and Tversky and others that have demonstrated that our minds are very limited in many ways. And it combines all of that into a mathematical framework that you can use to derive optimal heuristics for boosting people's decision-making competence. It also allows you to develop descriptive models of how people intuitively make decisions. And you can use those descriptive models in order to design the decision environment and the framing of the decision in such a way that people are more likely to make the better choice. And these descriptive models can also help boosting because they provide a model of how heuristics are learned. So resource rationality is in a way a natural extension of expected utility theory, which is sort of the previous gold standard computation level theory of good decision making. That one said human behavior should maximize the utility of the outcomes. And that's basically a theory for the behavior of optimal agents with infinite computational power. Now, resource rationality is a normative theory for optimal cognitive strategies for real people with bounded cognitive resources and finite time. It is still a theory of optimality, but it's a theory of optimality that takes people's cognitive limitations into account, and it shifts the level of analysis from behavior to cognitive mechanisms and representations. Before it was consider all possible outcomes, their respective probabilities, maximize over that, choose the action with the highest utility. And now it is just make the best possible use of the limited time and resources that you do have. So more formally, resource rationality defines optimal cognitive mechanisms as the solution to a constrained optimization problem over only those representations and mechanisms that the brain can actually execute. And within that space, it defines the optimal one as the one that maximizes the trade-off between the expected utility of the outcome of the action that you will choose if a real person with a real brain executes that strategy in the real world, minus the expected cost of the time and resources that will be consumed when that strategy is being applied. And that cost is primarily an opportunity cost, because the more you spend on deliberating on one decision that you might make, the less time you will have to act and the less time you will have to think about other decisions. So there's always an allocation of your limited lifetime across the many things that you might do. And if you put everything into one decision, that comes at a cost of you not being able to do good or get good outcomes for yourself for subsequent decisions. So that's basically a mathematical equation that you as a computational cognitive scientist can use to derive what is the optimal cognitive strategy for given a particular computational level theory of what the problem is to be solved, and for some assumptions about the cognitive resource constraints that you make about the mind. And if you want to improve human decision making, you can also use this equation to derive what is the optimal strategy that we should be trying to teach people? Mhm.
So we might have to, I think, might have to repeat it, but the question would be, what do you define as mechanism? Like policy, document learning, the environment, or what? Is it like more the threat?
So the question is, what do I mean by mechanism? This is a very general formulation. Depending on what assumption about the cognitive architecture you apply it to, the space of mechanisms over which you're optimizing may be different. You could apply it in the context of a cognitive architecture, and then the possible mechanism would be different production rules that define cognitive strategies in terms of symbolic representations. You could also apply it in a neural networks context, and then the strategy would be encoded by a weight vector. And then you would be trying to find the optimal weight vector that makes the network compute its output in sort of the most resource rational way. It can mean different things in different contexts. In the context of that I worked in so far, it was usually defined in terms of a policy for selecting a sequence of cognitive operations. But these are not really inherent to the definition. These are just different instantiations or applications of this general principle to different models of the cognitive architecture and what kinds of operations it has available. In my research so far, and also in other people's research, this approach has been applied to model human planning, goal pursuit, judgment under uncertainty, decisions from experience, as well as decisions from description, risky choice with multiple alternatives, strategy selection, cognitive control, proactivity, and a number of other things, which is to say it's a very versatile framework that you can apply to very different aspects of cognition. You could also apply it to reasoning, and I guess pretty much whatever you're interested in, you could probably apply it there as well. So my first take-home message is that the resource rational framework is a useful approach for discovering rational heuristics and for discovering rational models of cognitive mechanisms. While these models have been fairly successful at explaining a number of phenomena, as we have applied them and scrutinized them more and more, we've also found that in some cases, people systematically violate these resource rational strategies. So not only are people not unboundedly rational, but they're not even resource rational. Even within the limited resources that they have, they're not using them optimally. I cannot yet say exactly how close or how close people are to resource rationality, how far they are. In one study, we found it was about 80%. In another task, it was about 63%. So I think the key message is here that on the one hand, resource rational modeling gets us closer to the cognitive mechanisms that people actually use, but it does not generate sort of the exact strategy that people use, because people are not the optimal within the constraints of their limited resource and their finite time either. And the flip side of that is that when we know the resource rational strategy, we can improve how people think and decide by teaching them that strategy, because it is usually still better than the strategy that they're currently using. And the ways in which people deviate from resource rationality, on one hand, that they're using heuristics that are not well adapted to the particular situation. The heuristics may be well adapted to some situations, but then if you test them in another situation, even with some experience, they may not arrive at the heuristic that is resource rational for that environment. And sometimes they may have the different heuristics, including the resource rational one, but they don't choose them in the most adaptive way possible. And both of these can be addressed through boosting and teaching people better strategies and when to use which strategy. So therefore, my second take-home message is that we can leverage this computational framework of resource rationality in order to improve human decision-making by discovering resource rational strategies and then teaching them to people. So the question is, are there some factors we can use to predict and identify when people's strategies are resource rational and when they are not? One relevant factor is how much experience the person has in a particular environment with a particular type of decision. We find in our experiments repeatedly that if you give people a lot of experience and high quality feedback about their performance in a particular task, they learn resource rational strategies over time. So in situations where that is the case, we expect that people will have more resource rational strategies than in situations that are either unfamiliar to them because they don't occur much in real life, or when they do occur in real life, then people don't receive prompt and high quality feedback about their performance. That is the best predictor that I know of so far. Okay, so now I've introduced this general framework. And now I'd like to walk you through an application of that framework to improving human decision-making by discovering resource rational strategies and providing them to people. So this is called boosting. And the resource rational approach to boosting is to derive resource rational strategies and then either construct decision aids that guide people through the application of these resource rational strategies, that is approach A, or teach people to use these strategies on their own without any additional support, or if we change the situation and the way in which the decision problem is presented in such a way that people can use a resource rational strategy and are more likely to use it. So for instance, if a resource rational strategy is possible, if you have a particular type of information, this could mean providing that information to people so that they don't have to rely on really fallible heuristics and instead can use a resource rational strategy. And I'll introduce all three of them. I'll illustrate the first one first. So to construct decision aids that guide people through the application of resource rational strategies, we first have to model the decision problem that we are trying to help people with and the cognitive constraints that they have available to make those decisions. When we have that, we can apply automatic methods for machine learning in order to compute the resource rational strategy that is defined by our framework. And when we have done that, we can make it understandable and interpretable, for instance, by creating a flowchart or a list of instructions that people can follow. And that can also be automated. I'll first talk about the part where we discover the resource rational strategy, and then I'll talk about the part where we teach it, where we turn it into a decision aid. So as a proof of concept for this approach, we applied our strategy discovery method to the domain of choosing between multiple risky options in which previous research has already identified what kinds of heuristics work best. And as a proof of concept, we would like to see that in certain situations where those already known heuristics work really well, our method should discover the same ones. And in other situations where those heuristics don't work so well, it should discover other ones that work even better in those contexts. And we found that, indeed, our method can rediscover the heuristics that previous research has argued are rational, simple heuristics in those particular circumstances. So concretely, when you're choosing between multiple options based on what will happen in different scenarios, and one of those scenarios is much more likely than the other scenarios. So in this case, the brown balls much more likely to be drawn because there are just many more brown balls than other balls. Then the stakes are not very high. Then the research rational strategy is to only inspect the outcomes for this most likely outcome, and then choose the option that that gives you the highest reward if that outcome occurs, and not pay attention to any of the other outcomes. That's known as the take the best heuristic, and our method automatically rediscovered it when we applied it to an environment that had the characteristics that make this strategy rational. Namely, one outcome being much more likely than the others. However, now imagine there's thousands of alternatives, and it's a really low stakes decision. So the difference between the options may be as little as 1 cent. Would it really make sense to look at all of these alternatives at all, or would you just rather want to stop as soon as you find a good alternative? So intuitively, you would want to just find an alternative that's good enough and choose it. And in fact, that's the research rational strategy for such environments. So if we now make the stakes really low, then the optimal strategy will just inspect the outcomes of the different alternatives for the most likely event sequentially, and it will stop as soon as it finds one that is good enough. And then it will choose the alternative with that outcome. We call that the satisficing take the best heuristic, and that was also automatically discovered by our research rational framework and the methods that we use to compute research rational strategies. And that was not previously known. So this is an example where our research rational framework led to discovery of a previously unknown cognitive strategy. And people actually do use that strategy. So this was something that the previous research had overlooked. And by systematically applying this rationality to different scenarios, we were able to discover it and then confirm that it exists. Now, this was a proof of concept for the strategy discovery part. We also evaluated it in a domain of planning by applying it to a simple laboratory task that mimics the problem of planning a road trip. Here, the idea is that when you're planning a road trip, you want to maximize your enjoyment along the trip. So each location may give you some amount of enjoyment, and there may be some amount of cost of getting there, and you want to maximize the sum of that across all of the locations that you visit. But there are thousands of locations you could visit, and there's exponentially many different ways of combining them into a trip. So you can't really inspect all locations or all trips. Rather, you have to be efficient in which things you collect information about to find out how good it would be to be there. And then at some point, you just have to say, enough now. I have found a good enough route. I will just use that. And so the paradigm that we are applying our strategy discovery method to captures these aspects of planning a road trip. The participants are tasked to navigate the spider through the web of cache. Each of the gray dots has a hidden reward that the participant can find out by clicking on it. And each of these clicks has a cost, because it always takes time and effort to find out information and evaluate it. And so this video shows you what it's like for a participant to plan in this paradigm. And the strategy in this case corresponds to the sequence of clicks that they make, depending on what they've already seen in the past. So this is a strategy that one of the participants used. It starts expecting immediate rewards and then planning further into the direction when it has a positive immediate reward. But what is the optimal strategy for this? task. So we applied our automatic strategy discovery method to different versions of this environment. In particular, we applied it to one version where the range of possible rewards grows larger into the future. So in the long-term future, what you can achieve is much more variable than what you can achieve in the next 5 minutes. That seems like a plausible assumption. And when we apply our strategy discovery method to discover the resource rational strategy for such environments, the optimal solution is the future first heuristic, which inspects the potential final outcomes first and searches for one that is really good. And if it finds one that is extremely good, then it commits to going there without even inspecting the immediate and intermediate outcomes. Because in this particular environment, the variability in the final outcomes is so much larger than the variability in the immediate and intermediate outcomes that it's not worthwhile to inspect those, because they will rarely ever override what is the best path. So now that we have a method that we can use to discover resource rational heuristics for different environments automatically, we want to test if we can leverage that to improve people's decisions by constructing decision aids and providing those to people. So we discovered an algorithm that turns the resource rational heuristics into decision aids. We applied it to a number of different tasks. Applied to this task that I just showed you, it automatically generates a text that you see above the task. So it says, it recommends the participant or the person to use the strategy of first clicking the destinations that, or the destinations that correspond to the most long-term consequences. This would be these that have not yet been inspected, and to continue doing that until either all of them have been observed or you have found the highest possible reward. So this is a text that this method generated automatically. And when we applied it to this more naturalistic planning task, it also generated a text that is appropriate for this particular task. And this time it is about inspecting the costs of airports. And then we also applied it to yet a seemingly completely different task where you're choosing between different payment plans for a mortgage. And this time it recommends you that you should focus on the interest rates of different mortgages for the longest time period, which is also the latest time period. We tested if these decision aids are helpful in an experiment where one group was given the task with the decision aid and another group was given the same decision task without the decision aid. And we found that in all cases, the group that was provided the decision aid performed much better at the task than the group that was not given the decision aid. So we were able to boost people's decision-making performance with these automatically generated decision aids. So the question was, what information was the control group provided? It was basically provided the same information as the experimental group except for the strategy. I think we did inform all participants what the lowest possible hotel price was. And I think we generally, I'm not sure. I think that the benefit of decision strategy will be even larger if you provide less information. But even when we tell them about the minimum price, it was still very beneficial. Okay, so this is the first way of using resource rationality to boost people's decision-making competence by creating decision aids. The second way I'd like to introduce is discovering and teaching resource rational heuristics to people. So this time, rather than showing them the decision aid in a particular, while they're making a particular decision, we're just giving them training sessions. And then after the training sessions, they make decisions without any assistance. And we hope that at least in problems that are similar to the ones that we trained them on, they will then use the strategy that they were taught and consequently perform better. And the way that we're teaching these strategies, or at least one of the ways that we use to teach the strategies, is to let people practice and give them feedback about the extent to which their strategy is resource rational or deviates from resource rationality. And we tell them what the resource rational strategy would have done instead of the errors that they made. So the general idea here is that we give people a decision problem. We observe how they go about making the decision by measuring which pieces of information they look at. And then we give them feedback that is optimized to direct them towards the optimal heuristic. And that feedback is based on a technique for accelerating reinforcement learning called reward shaping, where basically the feedback signal is the difference between the value of the state that the action that you take gets you to minus the value of the previous state. So that if you make a mistake that gets you away from the optimal trajectory, then you get negative feedback. And that same principle can also be applied in this context where the actions are cognitive operations. So basically, we're teaching people to perform the optimal sequence of decision operations by giving them feedback on how good their choices were about which information to look at in which order. And this video shows you what this looks like in a very simple version of this training, where they're being taught the future first heuristic that I mentioned earlier. So this was a mistake. And whenever you make such a mistake, you get two types of feedback. On the one hand, you get a delay penalty. You have to wait, and that is unpleasant, especially if you have to wait for a long time and there's nothing you can do during the wait time. And then you also are given a tip of what the optimal decision strategy would have done. As you see, the optimal decision strategy would have expected one of the final outcomes on the paths that still look promising. So it doesn't recommend looking at these because you already know that all of those paths have some negative value on it. So those are not so promising. You should rather inspect the final outcomes of the remaining and still promising paths. You also get positive feedback when you choose the optimal decision operation. And that continues for a number of rounds. And participants usually learn some aspects of the strategy relatively quickly, whereas others take longer to learn. All right, and now the participant made the worst possible mistake, which is to act without thinking, without making a decision without having any information. In that case, they have to wait 42 seconds, which corresponds to just how much worse it is than using the optimal strategy. And that is usually a quite strong learning signal, and people learn not to do that again. And here you can see that this training is in fact very effective. On the y-axis, you see the proportion of people who use the future first heuristic when they are given feedback, shown in orange, versus when they are practicing the task without any feedback. And so the group that gets the feedback from the tutor much more rapidly discovers this optimal heuristic than the group that does not. And also, even after fairly large amounts of training, the group that was not given feedback doesn't discover that optimal strategy as often as the group that does. So learning is accelerated, and also we increase the proportion of people who discover the strategy at all. And then if we test people on an independent post-test task without feedback, then the group that was previously trained by the tutor performs better than groups that were practicing on their own, or got more conventional feedback about, did they move in the right direction? Basically, did you choose the right action, yes or no? is much less effective than teaching people and giving people feedback on the process through which they arrive at the decision. Mhm. So the question is, if we tested teaching people the strategy or instructing them in the strategy against giving them information that would be sufficient to figure out what the optimal strategy is. Yes, we have recently also done an experiment where we explicitly tell people about the probabilistic structure of the environment, basically telling them what is the range of possible rewards at each possible node. And that gets a subset of people to the optimal strategy, but not as many as get to the optimal strategy when they're practicing with feedback. So some people are able to use that information and then use the optimal strategy, but others no, don't. We have not tested it yet, so I don't know. Mhm. So the comment/question is, do the effectiveness of different ways of teaching people depend on individual differences? And I strongly believe that they do. And I also believe that by taking that into account and personalizing the instruction, we can make it even more effective, but we haven't gotten that far yet. One thing that we have tested is whether the training transfers to other more complex and more naturalistic tasks. And I think that's important because if we are training people on a simple laboratory task, that would not be very useful if all it did was improve people's performance on the laboratory task. So one encouraging finding that we have is that training in this very simple, very artificial 3-step task with the spider improves people's performance in planning a road trip in this travel agent task. So here you can see what happens after the training in the simple task. Everyone's frequency of using an optimal strategy drops dramatically, but the group that was taught by the intelligent tutor still has an edge over the people who practice by themselves or receive conventional action feedback. The transfer effect is not very large, and it's also brittle. Therefore, it could be even more effective if we were able to train people directly on real-world decisions that matter. One exploration we have done in this direction was to create an app where people get optimal feedback on their decision about what to do while they're trying to get some work done. So in this application, the user says, in the next 20 or 25 minutes or 5 minutes, I want to write my semester thesis. And the application knows, okay, writing usually requires Word and Google Scholar, but it usually doesn't require Twitter. And then when the user ends up going to Twitter, they get negative feedback and a reminder that you actually wanted to focus on writing. And when they then correct and go back to pursuing the goal that they actually had said they wanted to pursue, they get positive feedback. And then at the end of the session, they get some summary feedback about how well they succeeded at focusing on what they wanted to do during the session. And you find that that feedback can very rapidly, just within a few training sessions, increase the extent to which people stay focused during these focus sessions. So that's an example where giving people feedback directly on relevant real-world decisions improves relevant real-world decisions. Mm-hmm. Okay, so the question is transfer limited because people don't understand the structure of the environment? Could that be remedied by informing them about the structure of environments and informing them about environments where the strategy might work well? I think absolutely. I think it would also help to train them on a varied set of different environments that makes it easier for them to abstract out the relevant structure and not encode the environments in which the strategy is well suited in terms of superficial features. So these are two strategies that could help increase transfer. Okay, so I've just showed you the first and simplest applications that we've explored so far. We also have now developed machine learning methods for discovering rational heuristics for larger and more complex environments with high levels of uncertainty. This also includes partially observed environments where you cannot ever find out for certain what the outcome of a particular action will be, but you can gather more and more information about what it might be. And we also have addressed the problem that we never really know what the real world is like, such that our methods become robust to potential errors in the model of the real world and still generate useful strategies when the model that we give them is wrong. So the take-home message from this third part of my talk is that deriving boost from the principle of business rationality is a promising approach to improving human decision-making. I'd like to briefly show another approach to boosting and helping people discover business rational strategy, namely engaging them in systematic reflection about how they make their decisions and how well those strategies work for them in practice. That's something that you could do with a Socratic chatbot that asks people questions that guide them to insights about how to make better decisions. So we have created such a Socratic chatbot intervention that guides people through this reflective process through a series of questions that they then answer in writing. And we found that it boosts their learning of how to make better decisions in one of our paradigms. And it also helped them discover more business rational strategies in those paradigms. And my hope is that with this kind of intervention, we can create educational interventions for boosting people's decision-making and problem-solving skills, and potentially also interventions for preventing and potentially curing decision-making dysfunctions that have serious clinical and societal implications. My hope is that if we support people in adaptively learning from the outcomes of their decisions, then we can potentially even turn around the downward trajectory of someone who is not learning well from their decisions and their mistakes into the upward trajectory of someone who's really good at learning from their mistakes and therefore becoming increasingly more rational. So next, I could either go into some more psychological research on boosting goal setting, or I could skip ahead to nudging goal pursuit. How are we doing on time?
So we were thinking, since we got some time at the beginning, to go heading to the blog, and I can say
For talking or for talking and discussion?
And including this.
Mhm. So if I go through both talks, I think that would take about 20 minutes. If I only do the last one, that would be like 5 to 10 minutes.
Yeah, I mean, we decide or maybe so far.
Yeah, do people want more discussion or more content? So more discussion. Okay, more content. Okay, more people want more content. All right, then I'll go through both parts. Mhm. Okay, so even more important than deciding what to do in order to achieve your goals is having the right goals in the first place. So we also are doing research on how we can support people in setting good goals that on one hand reflect their values and on the other hand are also useful for taking action in such a way that you would actually do something that helps you live those values and realize larger goals. So these two components I refer to as value-based goal setting, which is finding larger goals, for instance, life goals that are consistent with your values. And the second component I call hierarchical goal setting is about breaking down your abstract long-term goals into short-term goals that basically form a plan that allow you to actually achieve those larger life goals. The approach that we use to help people find goals that really reflect their personal values is to get them to reflect and imagine how they would like to be remembered after they are dead. So in this exercise, they imagine observing their own funeral and listening to the eulogy and to the testimonies of their friends and loved ones about how they have positively impacted the world. And after they have thought and written about this, we then ask them, based on that, which goal would you like to focus on in the coming months? And then we compare the characteristics and qualities of the goal that this group sets to the goal that another group sets that directly got a goal setting prompt without first reflecting on how they would like to be remembered. What we found is that first, engaging this eulogy exercise substantially increases the proportion of goals that are about contributing to the community and the proportion of goals that are about having good relationships with other people. And at the same time, it significantly decreased the priority that people place on more extrinsic, instrumental things such as getting rich and being famous, and they don't change to how much they value self-expression. So this is a very significant positive finding, because previous research on well-being has found that people who prioritize wealth and status and image and power actually are very unhappy, and that people who prioritize more altruistic contributions, community, and relationships are actually much happier. And I think what is also true is that the latter group also has a more positive impact on the people around them and the world at large than the former. So just helping people to think about what they want to do for themselves in a way that is that gets them more in touch with what they value can be really beneficial. Now that we have an intervention, and I think this is an example where we modified the context and the situation in which they engaged in the decision of which goal to pursue. We didn't really give them a strategy. We didn't really nudge them, but we changed the context in which they engaged in their own goal setting. Now, once you have such a goal, how can we help people to actually make progress towards such goals? Often these abstract value-driven goals are not very concrete. It's not clear what to actually do in order to make progress towards them, and consequently, they don't have much of an impact. So to address that, we developed a chatbot that guides people through the process of iteratively breaking their goal down into a hierarchy of increasingly more concrete sub-goals. So a very high-level goal may have multiple long-term goals. Beneath it, each of those may have multiple midterm goals. Each of those may have multiple short-term goals. And eventually you get down to the level of a daily intention that you can pursue in a given day. Such hierarchical goal systems can be really effective, but people don't create them. But people may not create them on their own without guidance as much as would be good for them. So our chatbot asks people to imagine achieving their large, inspiring goal vividly, and then it asks them, now, in this scenario where you achieved the goal, where were you about halfway through that process? So imagine you have an inspiring goal for what to do this year. That would mean you imagine how you will achieve it, what all of the things that you will be doing in the year in order to get to the goal, and then the chat will ask you, okay, in this scenario, where are you 6 months after you start? And then that becomes a midterm goal, and again ask you to imagine achieving the 6-month goal, where will you be after 3 months? And so on, until you have something very actionable that you can do today. And then you have a plan, a hierarchical plan that you can act on. And in a preliminary study, we found that when we supported people in that way, they made more progress towards their high-level goals, and also experienced a greater alignment with their day-to-day behavior and their larger values that were inspiring the goals. So the take-home message from this part is that psychologically informed technologies can help people translate their values into goals and make progress towards those goals. This was not very computational, but I think it shows that we can at least use technology and psychological science to tackle some really important issues. And I think eventually we can also make this more rigorous and leverage computational tools there as well. And maybe that's a challenge for anyone in the audience who feels inspired. I think everything is amenable to computational modeling, but some things are more ready. In some cases, it's more easy. In other cases, it requires a bit more theorizing first. Okay, so then on to the last part of my talk, which is using nudging to support goal pursuit. So, as you remember from the introduction of the talk, nudging means modifying the way in which a decision is presented to people in such a way that they will autonomously choose to do what is better for them and for society based on their intuitive decision mechanisms. So, we can use research rationality to work out what people's intuitive heuristics are. We can have a reasonable rational model of what those heuristics are. And then we can simulate what those heuristics would choose for different ways of posing the same decision. So different ways of framing the decision, for instance. And then we can choose the framing that maximizes the quality of the resulting decision, given a fixed heuristic that we may have determined through research rational analysis. We applied that to help people overcome procrastination. So I think we've all been in the situation where some items of our to-do list just repeat day after day after day. They may be really important, but somehow we always find smaller, less important things to do instead. Why does that happen? One prominent and promising theory is that our motivational mechanisms are rather short-sighted. They care about how we will feel now, but they may overlook how we will feel a year from now. So they have an asymmetry where what happens right now has much more motivational pull than what will the consequences be in a year or in 10 years. And therefore, in situations where the short-term appeal and the short-term rewards are misaligned with the long-term value, our motivational system leads to bad decisions that we later on regret. If that is the case, we may be able to help people overcome procrastination by aligning the short-term rewards of each activity that they might want to pursue with the long-term value of that activity. In that case, we may be able to eliminate the motivational conflict between what you think you should do and what you feel like doing, and help people be much more motivated to do what is best for them in the long run. We can mathematically formalize this by saying that we want to add some additional motivating incentives or rewards to the already existing rewards in such a way that the purely short-sighted strategy that only cares about what it will feel like right now will make the same choice as the optimal far-sighted strategy that is maximizing the long-term impact. So this, yeah. And you can prove that the incentives that achieve that can be computed by the simple equation that says each action should receive an additional incentive that is equal to the expected value of the state that you will be in when you have performed that action minus the value of the current state. So basically, the increase in long-term value that you achieve by doing the action should be given to you right when you do the action. If that were the case, then these two motivational mechanisms would agree with each other, and it would be much easier for us to do what is best for us in the long run. Now, given that we have formalized this in these mathematical terms, we can actually compute these optimal points and then put them on people's to-do lists. And by doing so, we change the environment in such a way that a short-sighted motivational mechanism that would normally always prefer a fun and easy task to a dry but very important task, to instead choose the task that gives you more points now, which happens to be the dry and boring task that you didn't want to do in the initial scenario. So to implement that, we model people's projects in the pursuit of those projects as a Markov decision process where you have to sequentially choose which tasks to do given which tasks you have already done. You then get an immediate reward based on how it feels to do that task, and you advance to a new state where that task has been completed. The goal is to maximize the long-run sum of rewards, which may often be dominated by the large value of having completed some important projects, rather than the immediate short-term rewards or discomfort for doing a difficult task. And we can compute exactly how valuable it is to be in each of these different states and what the optimal action is to do and the optimal sequence of actions. We do that on a web server. And then we convert the optimal value functions that we computed in this way into point values that are added to people's to-do lists. You know, these point values motivate people to do what is best for them in the long run. We tested this in a series of online experiments. We gave people a number of daunting writing assignments that they had to complete by some distant deadline, and only after that they would receive any reward. In the control group, they just got a plain to-do list with these different assignments. In the experimental group, we added optimal point values to that to-do list that we computed according to our method. We found that while the control group often procrastinated so much that it didn't even get started and therefore missed the deadline and missed out on the large reward, people who were supported by optimal gamification almost always started and completed all the tasks on time. So that reduced procrastination from 40% of the participants to only 15% of the participants. In another experiment, we tested if this approach can also help people prioritize between more important projects and less important projects. In this case, we found that the method automatically generated incentives that got people to prioritize the more important tasks more often, so that the proportion of people who focused on what was most important went up from just about 2/3 to almost 90%. So the take-home message from this part is that we can leverage artificial intelligence to empower people to nudge themselves to do what they want and to thereby be able to overcome motivation obstacles to doing what is best for them in the long run. So in summary, I have argued that resource rational modeling is a promising approach to discovering good heuristics for decision making. I have argued that even though these resource rational strategies are often a good starting point for modeling how people make decisions, people still have a lot of room for improvements, and teaching them resource rational strategies can make them better at decision making. And I've illustrated that if we teach people resource rational heuristics, they actually get better. Then in the next part of my talk, I show that psychologically informed technologies can help people set better goals and make better plans for how to achieve them. And finally, I showed that we can also leverage our computational methods and models to help people overcome motivational obstacles to pursuing and achieving their goals. Thank you very much. I'm looking forward to your questions. Okay, so the question is, what do you do in cases where relevant outcomes are not easily quantifiable? I think one approach that one can try is to elicit people, how much people value these different outcomes by having them choose between hypothetical scenarios and working out how much people implicitly value different things based on their choices. So basically using behavior in order to infer value. And then there may just be some areas where we don't have a sufficiently clear and good quantitative understanding for these methods to be easily applicable. But usually we can still at least rank alternative scenarios and use the tools that researchers on sort of judgment and decision analysis have developed to help people get to sort of the best estimates that they can get to. But sort of your question already presumes that there are certain cases where a quantitative approach is not applicable, and in those settings, the quantitative approach is not applicable, sort of by definition. And I think the main discussions would be like, is this particular scenario really one of those types or not? And I think that that's sort of a difficult case-by-case decision. I think for the purpose of my research program, so the main thing that matters is that there's sort of a sufficiently large space of things and a sufficiently large space of people where estimates are available that it can be helpful for many things. Yep.
Science, what actually is. In some scenarios here, it's quite clear. It's
Okay, so the question is, how do you even know what is good or bad? And I think that ultimately comes down to your moral theory. My moral theory is that human well-being is, and also animal well-being, and more generally the well-being of sentient beings, is what has the ultimate moral value. And we can work out how good or bad different actions or outcomes are in terms of their consequences on the expected well-being of all of the sentient beings from now until the end of time. So this is sort of my moral framework that I would use to work out what is good and bad, and to try to quantify things in terms of their value, even when it's not obvious what that value may be. So an apple and a banana, or apple and orange, may not seem comparable, but for one person, the orange will just make them much happier than the apple. And in that case, the orange has more moral value for that person. Giving the orange to that person has more moral value than giving them the banana. And so that's basically how it would work out, this comparability and quantifiability issues, when that would be important. I'm taking a utilitarian consequentialist moral perspective, but I think it is tricky. What is the right way to apply it, and what is the right unit of analysis? If you apply to an individual decision in a trolley problem, the utilitarian decision would be to push the fat person off the bridge. If you were to apply it at a societal level, to the level of norms, and say, okay, which norms should society have so that well-being is maximized as a consequence of society having adopted that norm, you would probably end up with a norm against killing being utility maximizing. So I think it's more subtle and more difficult what exactly the implications of this utilitarian moral theory are. And they're not necessarily all that repugnant as might sometimes seem in certain thought experiments. No, it is not contingent or dependent on adopting that particular moral framework. Whatever you, as a person who might want to apply the framework or any tool for helping people regards as valuable, or what the person themselves regards as valuable, can be supported. It's just that if you have deep uncertainty about what should we even assign value to and how much value should be assigned to, then that kind of moral framework could be, people could apply that framework to figure out those more thorny questions. But you don't need it if you just feel like, oh, I know what's good for me, that's what I want, so I put value on that. That also works. And the resource rational framework is really not married to that deep moral commitment at all. You can just say, well, the goal is to maximize task performance in my psychophysics experiment, and you can apply it to that as well. Mm-hmm.
More general question about the implication in that you can the outcomes to that people choose to do the task. The person less. And secondly, there is more important. So I'm wondering what are the underlying psychological activities? Like, why do people choose to do more than that? I'd rather more professional less because it's my dogs the list are clear. Or why do we choose to be more important?
So the question is, what exactly is the psychological mechanism behind to-do list gamification helping with prioritization? And one possible answer is that the main effect of the main component of the intervention is not just to give people a list, but to put point values on the individual tasks of the list. And more important tasks get more points because they lead to more improvement and long-term value. that on the one hand signals to the person what is most valuable and it's easier to choose. And it's also more motivating for the person because they can get a large number of points now and so feel good about having achieved that. So on one hand, it simplifies the decision problem by clearly singling out one task as the one with the most points and also making that one more appealing and more rewarding to do.
The real world, I think the following aspect. There is some sort of hierarchical structure that you need to follow as before. And so if these strategies are provided by values, let's say, speaking or we think that will eventually learn to do it themselves. That's a little learn how to solve the math problem. How can these how students learn themselves? What are the mathematical problems?
I think the feedback approach is one that is really supporting learning rather than just telling people what strategy to use. So that's an example where the approach is used to foster learning. Yes.
I have a question about the relationship between this theory of results that so it seems to me like was resource selection or derivative or what maximizes flexibility, but this kind of reaction we would take or constraint agent would take that gives the constraint but still it's not flexibility.
So the question is about the relationship between resource rationality and expected utility theory. So we are still using the tools of expected utility theory to evaluate what cognitive strategy is best, namely the one whose application on a real brain with cognitive constraints would yield to actions that have a higher expected utility than actions that would be chosen by trying to execute another strategy. So in that sense, we're still building on expected utility theory, but the optimal actions are usually different, especially in cases where computing the utility maximizing action would just be intractable. The resource rational strategy may actually choose actions that are suboptimal from the perspective of expected utility theory, but they're basically as good as you can do on average when you have all of these time constraints and limited resources.
You don't actually work out what the action is.
We usually work out the expected utility of the choices that the resource rational strategy would make. We don't necessarily need to know what the utility maximizing action would be, but it's about equally difficult. So at least as the analyst, we still need the computational power it would take to do expected utility maximization, or at least something to approximate it. But the difference is that we, as the modelers and the researchers, can use supercomputers, and people don't carry around supercomputers in their brain, and they have to make decisions in real time, and we can invest a month of compute time to work out what the optimal strategy is. I have to move on to another meeting, so I think we should wrap up. Maybe one last question. Yes. Do I believe that people are resource rational? I believe that people are not resource rational. I believe that resource rationality is something for us to aspire to. That is sort of the best we could do, but we are not optimal yet. So it's a guiding principle, a guiding light, but we have more work to do to get there. Thank you for this question.